Welcome again. This is Bob Dust, your instructor for the ITD 130 Database Concepts class. Today we're going to continue our discussion about the aircraft charter problem, for example. And so I trust you have already viewed the PowerPoint presentation and how we normalized a denormalized database structure, table structure. And today we're going to use SQLDBM to create a diagram from our aircraft charter project. So we'll start with, we already have some key entities defined. So we'll start with some of those. So I created a new project in SQLDBM, and I'm going to create a table from what we had started with the other day, and that is the charter. Remember, so an aircraft charter is a event where we create a charter flight. So our entity name is charter. Our primary key is charter ID. That would be an integer. And then we have attributes of departure time, which is a date time data type. We have what time do we return. That is also a date time data type. We have a destination. And we have how many hours it took to fly. Now here I'm going to make this a decimal 18,2. This says 18 digits of precision, of which 2 of those are decimal places. And we'll also have how many hours we had to wait. And we'll do the same as that, 18,2. So here is our charter entity. Next, we're going to move on to who the customer is. We'll create another entity over here for the customer table, and we give it a primary key of customer ID. And we could add a lot other things in here. We'll keep it simple and just call it a name. And we now have our customer entity. Now a customer has many charters. A charter is for only one customer. We're going to create a non-identifying relationship where the parent is the customer and the child is the charter. You notice it puts the foreign key over here to the which is the primary key of the customer table. So we take the primary key of the one table, this is the one table, and put it in the many table. A customer has many charters. A charter has one customer. So we take the primary key of the one table, customer ID, put it in the many table. And you also notice it's color coordinated here, so that customer ID it's a different color than the other attribute, so we know it is a foreign key. Okay, so let's move on. Next we'll do an aircraft. We create our table here, and we call this the aircraft. Aircraft ID, data type int. And here we have the name of the aircraft. We have the tail number. We have, that's it. We have the aircraft. This is the aircraft that flies this charter. Again, we have a relationship here. An aircraft can fly many charters. A charter has only one aircraft. That would be a non-identifying relationship. For the primary key of the one table, we start with the one table, and then we go to the many table. So the parent is the one, and the other is the many. Again, we see we have a foreign key here, which takes the foreign key from, the primary key from the aircraft table, and here into the charter. Now, an aircraft is of a particular type called a model. Let's create another entity. We'll call this model. And this would be the name. I'm going to move this around a little bit so we can see it better. We have the capacity. This is how many passengers can this hold. The hourly rate. And the wait time wait. All right, I will move this further down here again. And we'll create another relationship between model and aircraft. A charter has an aircraft has a model. Let's continue. Next we need pilots. Let's create a entity for pilot. Again, all this came from the PowerPoint presentation we did previously. So I hope you saw that first so you understand why we're doing these. And pilots have a name. Of course, you can have first name, last name. We're going to keep this simple though. Pilots also have an hourly rate. And they have a wait time. So, pilots fly airplanes, but they have a relationship with the model. So, if a pilot can fly a particular model, then they can fly any aircraft of that model. So the relationship is actually between pilot and model. A pilot can have many models, can fly many models, and a model can be flown by many pilots. That is a traditional many-to-many relationship. So we will identify that with a table called pilot model. And we have, we'll add something here. We'll do that. Now this is a many-to-many. So we will create an identifying relationship because a row in the pilot model table does not exist unless there's also a row in the pilot table and the model table. So we go pilot to pilot model. Because we made it identifying, notice that the relationship line is solid as opposed to dash for not identifying. Also notice that not only did it take the primary key of the pilot table and add it to the pilot model table as a foreign key, it also made it as part of the primary key. We'll do the same thing with the model to here, and it does the same thing. Now, if pilots are certified for models, we can add in here an attribute of certification expiration date, and that would be a data type. So here's our relationship. Pilot can fly many models. A model can be flown by many pilots. And the last thing we need to do is to add our passenger list for the charter Let's add a table for passengers. And passengers have a passenger ID and a name. Notice a passenger is not necessarily the same as the customer. The customer is the one who hires the charter, but they may be flying other people on there. So keep those two separate. Passengers, the people who are on the plane. The customer is the one who's paying for it. So a charter can have many passengers, and a passenger can fly on more than one charter. That would be a bridge table, a many bridge table. We'll add that here, and we'll just call this manifest. And the manifest, because it's a many bridge table, again, we use the identifying relationship. Here, we go from charter to manifest, and do another identifying relationship from passenger to manifest. And there we have completed our diagram using SQLDBM. We can visually see what our model looks like. We have several entities here. Entities have various attributes. Each attribute has a data type. Foreign keys are identified by the FK symbol. Also, it has its own unique color. As you see here in this bridge table, notice we added another attribute called certification expiration date. So here is our model, fairly easy to design. And once you get familiar with doing these, you can see the visual relationships between the various entities. So we can chase relationships down from passenger to manifest. Oh, we need one more here. I'm sorry. We need a relationship between a pilot and a charter. We need to know who flew on this particular charter. That would be a non-identified relationship. We would go from pilot to charter. And now we know who the pilot was for the plane. We know who the customer was for the charter. We know who the passengers are. We know what aircraft they flew on. We know what model of aircraft that was. And we also know that the pilot was certified. And we can, with a good design like this and a nice tool like SQLDBM, we can chase all this down. So that concludes our discussion on the aircraft charter. Now remember that this was based upon the PowerPoint presentation provided earlier, where you can see how we broke down the denormalized database structure into a normalized one. Hope you enjoyed this, and we'll catch you next time.